Thanks, Ian. So this talk is going to be about duck typing and it being for the birds. So about me, I'm a developer and I guess manager at IBM Watson Health in Cleveland. I used to be pretty heavy into databases, so you can follow me on Twitter at SQLBrad if you're interested. I'm currently working my way through grad school. I'm married and I have a small child, and I enjoy baseball, beer, and whiskey. So I think it's important to understand the title of this talk. And I didn't really know what it meant when I first started. I just thought it was kind of a compelling idea. The notion of blank is for the birds. But the topic really came, or the title really came out of the end of World War II. And it was an expression meaning that the plant seeds in horse manure are totally worthless and they're for the birds. So you can imply that it's for the birds. So I don't really think that duck typing in Python is worthless. I just thought it was kind of a compelling topic and maybe some people would show up to hear about it. So you're probably wondering, like, why am I even giving this talk? I don't really enjoy public speaking, but it gets better over time. But really, I unfairly hated the idea of static type annotations in Python. A coworker of mine came back from PyCon in 2017 in Portland and was like really amped up about what static typing could do for Python and was like super excited to implement it. And I was like, hey man, if I want to write Java, I would just write Java. And so I kind of, it wasn't really fair to him, and it took about a year, and then I went to PyCon, and I was like, hey man, static typing is really cool. We should do that. So static typing in Python is a relatively new concept. I think officially supported kind of came out in Python 3.6. There's a couple PEPs we're going to talk about later that paved the way for it. But I don't think that a lot of people are really using it or implementing it. So just kind of curious, how many people in the room have heard about the concept of static typing in Python? Okay, most of you. Surprising. So the other part of that is how many of you guys are using it in maybe production code? All right, perfect. So not very many. So there are kind of two disciplines that I kind of want to discuss for this talk. There's software engineering and development, which I think of as the actual implementation of code. And then there's computer science, which is kind of like big O and talking about algorithms and runtime. And for this talk, I really want to focus more on the software engineering and development. I'm going to show a lot of syntax and code examples. So I'm not going to get heavy into the theory for a lot of this stuff, but I think this is more applicable. So software engineering for this talk is going to kind of win out. So you're probably wondering at this point, for some of you, like what is even static typing? And so typing, static typing and dynamic typing typically refers to the point in the code execution or compilation when your variable types are checked. So for static typing, that happens at compile time. But so that leads to another issue. You might get compilation errors. And so if you've ever written Java and you try to do something like this, where you're adding a string and a numeric value, it'll throw an incompatible types warning or error when you actually run the compile. So just so you're familiar, I'm going to run through a couple commonly statically typed languages so you can see the syntax, and you'll probably, if you're familiar, notice that it's a little bit more verbose than what you're used to in Python. And there are a lot of similarities between the languages. So I created some little hello world examples for Java. And you can see here, we're defining strings as actual strings. Same thing for C, C++. And then for people that work primarily with Windows, we got some C#. And so what is dynamic typing? It's kind of the opposite of static typing. The variable types are checked at the runtime of the code, similar to how Python works. But that can kind of lead to runtime errors. So similar to the Java example, if we take a string and we have a number and we try to append those values, this will result in a type error. So any of you that have written much Python have probably come across this at least once or twice in your code. So what is duck typing? Oh no. Well, duck typing is really just another word for dynamic typing. People like to say if it walks like a duck, quacks like a duck, and swims like a duck, it's probably a duck. It's just a lot of words for dynamic typing. So to be fair, I'm going to show you a few dynamically typed languages similar to Python, first being Python, where you don't have to declare strings. You just assign the variable to your text. Ruby is also very similar. And then Perl. So all these dynamic typed languages are very similar. So here's a dynamic typing example using Python with f strings, where we have a variable named var. I set it to Brad, and then I reassign it to the number 1. And this is really oversimplified, but it's pretty amazing what's happening really at runtime. We take the variable var, and it's a string, and then immediately on the next line, it becomes an integer, and we didn't have to reassign it or anything, and that just happens automatically as part of Python. So there's another topic that comes up when you're talking about static typing and dynamic typing, and it's strong versus weak. And there's a lot of different opinions as to what strong and weakly typed languages are. And if this is a topic you want to explore, I encourage you to read into it. So I'm going to go over some generalizations in which I find to be true about the terminology, but it's not super concrete. Strongly typed languages are typically going to be statically typed languages. That one pretty much holds out. Statically typed languages are not necessarily strongly typed languages. For example, C is considered a pretty weakly typed language with the way pointers are implemented. And dynamic typing does not mean it's automatically a weak typed language. There's some debate about that one, especially some people think Python is strongly typed. Some people say it's weak typing. I'll let you decide. So you're probably wondering, like, okay, we learned some stuff. Is static typing something that I should look into? Is this something for me? And so I'm going to go over a couple code examples, and if you find that you're doing this in any of your code, it's probably something you should look into. So if you have any if blocks where you're checking the type of a variable to see if it's a string or an int or a specific object, this is something that maybe static typing could help. In another similar way, you might be checking the instance type. Or maybe the most Pythonic, where you're just going to try and then accept the error, but you're catching type errors. Or pretend this is a PyTest and not a unit test, but you're writing tests to check different instance types and things like this. Or you're just a fan of really readable code. Or you work in a team or participate in code reviews. Or you contribute to open source projects, or you're an open source maintainer. If you answered yes to any of these scenarios, I think that static typing is something that you could probably benefit from. So here are the 3 Python enhancement proposals that really paved the way for implementing static typing in Python. The first one really gets into the computer science theory behind how the type hints are going to work. 484 and 526 are really the implementation of type hints. So now we're going to get into the kind of actual like coding portion of the talk, so you can actually see how the syntax looks and it's implemented. And so the most basic form is you declare your variable name, colon, you specify the data type, and then you initialize it to the value that you want it to store. So here are the most basic examples of, without doing any imports, you can define integers, floats, bools, strings, and bytes right in your code. And obviously they're respected, so if we run this, oh no. Well. All right. Well, believe me that it's there. So provided by the typing library, you can import lists, sets, dictionaries, and tuples. And here are examples of how they're implemented. In a very similar way, you use the variable name, colon, and then the type of object, and then typically in square brackets, the data type that that list or set is going to store. Dictionaries, you specify the key and the value, and tuples, you specify each element in the tuple, the data types. So continuing on with that, some of the more advanced items are any optional, and union. And so if you have a union, it tells you that that data type will be either one of the two items or multiple items in that list. So in the risk level list, it's going to either return an integer or a string. Optional is what you use if your variable may be set to none. And then there's also the any, which can be used if you don't know. If your code is really complicated, it may return some random object or data type. So here's a method that I created, distance, that calculates the distance between 2 points. And you can see it's a pretty standard Python method definition, except that we have a colon after the arguments and the data types that it expects, and then an arrow on the right-hand side pointing to the return type of that method. So in this instance, this method expects 2 integers, and it's going to return an integer. So if we run this, we get 4 as the result, and it's a type int, as expected. So here's the same method, also expecting 2 integers and an int as the return type. But what happens if we pass it to strings? You know, we're using static type annotations, so we would expect that this would not work. But static type annotation in Python is not respected. You use annotation checkers to make sure that you're actually passing the correct arguments. So if you tell it it's an int and you pass a string, it's still going to try to execute your code and will still throw type errors. So here's a simple class, dog, that I created. And here is how to pass named parameters and then keyword args into an init function. So you can see here that it still returns none, but it knows that the dictionary that it accepts for the keyword args is going to be strings. And then that the number of paws on this dog, and if it's a puppy, are ints and bools respectively. And then you can initialize a dog, passing it your dictionary, and then call a method on it. And so it tells us that this dog that we created is a type boxer. So there are a number of libraries that you can use to help with implementing static type annotation. And the ones that I'm going to talk about for this are Pyre, mypy, MonkeyType, and retype. So Pyre can be installed using just pip install pyre check. It supports Python 3.5 and newer. It doesn't currently run on Windows. It's OS X and Linux only. And it's available under the MIT license, and it's actively being maintained and developed by Facebook. So a little example of what Pyre can do for you. I just have a broken method out here that is going to call my distance function that we created, and it's expected to return an integer, but I actually have it returning an empty string. And so we can see what Pyre will do when it does its checking for us. So we're just going to run the Pyre check command and check on the output. So because I'm running this in the notebook, we get a bunch of warning messages here in red that are kind of hidden in your normal shell. But the actual message here is that the distance broken Python, I get the line of position, has an incompatible return type that we expected this to return an integer, but it actually returned a string. So Pyre has several IDE integrations available. You can run it as part of a standalone utility, like I just demonstrated against your code base. There are enhancements that you can run so it respects caching. You can have it run automatically when it detects files were changed, and so forth. But to work natively in your IDE, it will work with VS Code, Nuclide, and Atom currently. I believe other plugins are currently being developed, but Pyre is pretty new. I'm going to compare this a little bit to mypi, and it was developed by Facebook as a mypi replacement, as it was much faster for large code bases, was really the driving reason behind its development. So Pyre supports error suppression. So when you go ahead and you start using some sort of static type checking, you're probably going to have a lot of instances in your code that are not annotated properly. And in order to just pass the test, you can use these annotations. So you can use the comment Pyre ignore next to the line that you'd like it to ignore at runtime. You can put it on the line after. This will ignore the previous line of the comment. And then you can also look up the specific error codes and put them in a list with Pyre. And this one in particular will ignore return errors. So the second library is mypi. This is probably the most commonly used one. It's installable by pip install mypi. It supports Python 3.4 or higher. It's licensed under MIT, and it's actively maintained under the Python project on GitHub. So the first piece, here's our broken distance method that I demoed earlier, where we're passing a string instead of an int into our function. And if we run mypi against this, we can see that it returns 2 error messages telling us that the arguments have incompatible types. So similar to Pyre, mypi is typically run outside of your IDE, but there are also plugins that allow this to function. So a scenario where your function or method is working as expected, as in this example, when you run the mypi command on the working code, it'll execute, and it doesn't actually return any output. If you look at the number 49, you can see it change as it executes, and it increments. So mypi, being significantly more mature than Pyre, supports a number of other IDEs like Vim, Emacs, Sublime Text, PyCharm, and there's also a Flake 8 integration that you can use with mypi. So mypi also supports error suppression in a little bit different way, but it still supports the type ignore comment, similar to Pyre. So you can throw that on the line of code you wish mypi to not check, and it will ignore it when you run the check. You can also run mypi with the command line option, ignore missing imports, and then give it the file or the path to the project that you want to check. And this will ignore any missing imports, so you can ignore entire modules doing this. So the third library that I kind of like to talk about is MonkeyType. It is maintained by Instagram, licensed under BSD, and it supports Python 3.6. So MonkeyType is a library that supports automatic type annotation. It's really helpful if you have a large code base and you want to switch to using static typing. It can run in the background for you and determine the types of variables passed into your methods and create the annotations for you automatically. So I'm going to run through a quick example of how MonkeyType works. So I split the code out slightly into a distance py and a myscript py for this example. And I just give it the path to where the code lives, and I tell it MonkeyType run, and then the Python file that I wish to execute. So the code on the previous slide, the difference between 1 and 100, it returned 99. And so MonkeyType gathered the inputs and outputs of this. And so if we want to, we can tell MonkeyType to return us the stub. It creates a stub file of what the annotations should look like. So we can do that now. So it generates a stub file with the method definition of distance, and it automatically created the ints for the start and end position for us. And then the other thing that you can do is you can apply that type annotation directly to your code. So the code here in distance doesn't currently have any type annotations. If we say MonkeyType apply, it will go out and blend the annotation file and the code file. And then if we look at the code itself, now you can see that the distance method tells you that it expects an int for both positions and returns an integer. So how does MonkeyType actually work? Because it's pretty powerful. It uses the syssetProfile hook that's available in Python, and that allows it to record the data types passed into functions. It records the data types yielded from functions, and it records all this information into a SQLite database in the directory of the project that you're working in. So if you're curious about what MonkeyType actually captures, we can connect to the SQLite database and dump out this data. So you can see that the method name is in here, the argument positions, end position, start position, and then the type that it expects. So retype is the library. It's provided by Lucas Langa under the MIT license. It supports Python 3.6. And retype is what's used by MonkeyType to allow the application of the annotation files directly on top of your code. Lucas also maintains the mypi Flake 8 integration, which is worth checking out. So that library is required for MonkeyType, but it's not something that you really have to run independently. So how do you get started? I would say attending a static typing talk in Python is a good place to start. But definitely take some time and compare Pyre and mypi. In my examples, I found that mypi worked a lot more how I would expect it to. Pyre had some sort of flaky behaviors in finding issues where I was passing incorrect parameters to methods. And mypi seemed like it was much more consistent with what I would expect. You can look on GitHub and see the number of dependencies to a project. And when I was working on this, mypi had like 1,600 projects listed as dependencies. And Pyre didn't have any. But I know that Facebook is definitely using Pyre, so at least one large company is using it. And evaluate MonkeyType. It's pretty powerful. I gave you a very brief example of what it can do. But it's not perfect. You're probably going to need some human intervention to review the annotation files that it creates to make sure that it's correct. Install IDE plugins. So some of these examples I gave are pretty simple, where you're passing strings into functions or methods that expect ints. But like the linters built into your IDE are going to flag that before you even have to run the type checker if you're using the annotations. So that's really powerful. Start easy. Find methods and variables that are easy to implement using basic strings and ints, and just start with your type annotations there. Maybe start with new code bases. It's a lot easier to start fresh than try to maybe go back and implement type annotations into a legacy code base that's kind of in maintenance mode. And suppress errors. Don't feel like you need to do it all at once. There's a lot of ways to suppress errors that I showed. There are also more. And when you start small, it can be pretty rewarding to watch as your error count drops off. And then integrate this with your CI workflow. If you're deciding that your workflow should support type checking, at least make sure your code is conforming to that before you merge it into your master branch. And there are a lot of tools that allow you to do this. So all the slides in the code are available on my GitHub page. This all runs within a Jupyter notebook, so you can clone the repo, and there are instructions if you want to run through the notebook, and you should be able to execute all the code examples. Thank you.